Yes, we're live now. So welcome everyone for our live weekly stream on Twitch. We're very excited today to have Denis Baltor joining our live stream. Denis is very active community member and he's a software architect and engineer, backend engineer as well. So how are you today, and Denis?
Hi, Fawaz. I'm very well, thank you. I hope everyone here also is having a really good day, and hopefully we're gonna spend a half hour talking through some interesting stuff.
Yeah, so I'm based in Liverpool in the UK. Where are you based now?
I used to live in the UK, but now I'm living in Portugal, so I'm out of Lisbon now.
Must be very nice weather over there these days.
Usually, yes, but just by chance today we got some cloudy weather, but yeah, not too bad. But I hope I'm trust the sun will be back soon.
Yeah, so here we had like a couple of days which were really hot. So it feels like it's early summer, but yeah, everyone is happy about this kind of weather because we don't get to see sun much often. So I'm sure that's you enjoy it over there. So maybe we do kind of like introduction, basically about your background, what you've been doing, how did you come to know Hazelcast, and we take it from there.
All right. Thanks for having me, Fawaz. So yeah, I started my career working as a Java developer way long ago, a bit before 2000. And then so at that time everyone was coding Java for the enterprise applications. I got that, and I worked with Java developer and then backend developer for 10 years or so, and then I spend some time working with solutions integrating different products. That's I At that time I started wearing a hat of a solution architect, and I spent some years on that role. But I really missed to work with software engineering and coding every day. So I decided to come back to work as a developer, and then and I spent some years working in a bank as a backend developer again, and I managed to join a Pivotal when Pivotal was taking care of Cloud Foundry platform. And also what they launched a platform for Kubernetes. So at that moment, I joined then as a platform architect. But my job was not related too much in terms related to infrastructure, and was more kind of a Spring Boot advocate. So help our customers figure out how they could migrate their Spring Boot applications into Cloud Foundry, and then on Kubernetes, following some good practice, the 12-factor patterns. So in order to reap the benefits of a cloud-native platform, our application needs to follow some guidelines, in order to be elastically scalable, and things like that. So I spent some 3 years with them, and then I joined some consultancy companies in order to be more closer again to the software engineering, because I noticed I was spending too much time talking about platforms, and not having so much fun coding business solutions. So yeah, so rather than tell people how to code, I decided to come back and code myself with our solutions. So that's what I've been doing the latest a couple of years now.
Yeah, that's great to hear. So did you know we have a very large community for Spring Boot who are using Hazelcast? Like it's really active in using.
Yeah, exactly. Yeah, I really enjoy a lot to work with Hazelcast, and also well, being in the Java world, I think I really have so many good memories for working with Spring Boot, and because well, it alleviates a lot of the burden. Before Spring Boot was really not so great working with Spring, and so many XML files that bean configuration was really annoying. And then people start creating different frameworks, and then that was a wake-up call for the Spring guys, the Spring community, and then they came up with the Spring Boot. Probably was around 2015 or so, and I that was just by chance the time when I came back to left behind this software solution architecture role and start coding backend code again, and just was a lucky coincidence that I managed to escape from that XML hell and start working with Spring Boot. And well, Hazelcast is really amazing solution cache that help us to do a lot of things and with so much benefit and with so little mess. So it's something that you can just leverage. I'm gonna cover a little bit of our application that presented the case for today. But hopefully people will see how easy it is to set up a really enterprise-grade application with Hazelcast and Spring Boot.
So yeah, that's great to hear. So I'm give all excitements now for you to share. So for anyone listening and watching us live now, feel free to leave your questions below. I will make sure to get these questions to Denis towards the end. So type in your questions. I will list these questions and send it over to Denis. So with that being said, stage is yours if you want to share your screen now. Thank you.
Sure. Thank you. So can you see my screen?
Yes, yeah, we can.
All right. So the story today is about an interesting case we experienced at the beginning of this year. Actually, it started the end of last year during the Christmas season. So let's crack on. Just a quick introduction about myself. Yeah, I'm a backend engineer. I've been working some time with Spring and Java. Also, I was very lucky to join some companies where I could experience firsthand the cloud native way of working, and also really exciting practice, like the true agility that we can get when we forget about all those ceremonies that doesn't bring any value, and we actually start focusing on working every day and bring value with quality code and not so much fuss. So yeah, that was a bit of me. Anyone who wants to talk to me can reach me out at LinkedIn. So yeah, just feel free to talk about anything you like. So this was the application architecture we are going to talk today. And this application actually is seems to be a very simple application in terms of the architecture. It was application in charge of an inventory of a really large supermarket chain in UK. So the application was running, is running on the Kubernetes EKS. It got an API gateway in front of them in order to load balance all requests. Despite of the workload, we just need 3 pods to take care of everything. And the application uses Aurora database in order to store the database, relational database. And also got some events from some messages from SQS. So once in a while, some events happen, message comes through, and the application triggers some process. And that was actually the problem we're going to talk about today. the challenge we had is the application is really supposed to handle a high volume workload with more than 200 transactions per second in the peak hour. And that was a bit of challenging how we could process everything and reply the request as fast as possible. So that's when we reach out to Hazelcast as cache, in-memory cache. I know that today also we got a Hazelcast data streaming platform that is a completely different set of solutions, very interesting as well. But for this particular application, we are only counting on Hazelcast as a cache, the classic use of Hazelcast. And so we decided to implement the cache aside pattern, where the application we bring Hazelcast as a memory cache. All data is stored in Hazelcast, in order to make it easier for the application to start. But when the application needs to read the database, go first to the Hazelcast. If it's there, the data is read. Otherwise, go into the database, read it from there, and update the cache. But also, we can't forget about writing keeping the cache and the database synchronized. So all writes has to go through both. So that's basically the cache aside pattern. And we we adopted this pattern, and it was so easy to adopt this pattern because Hazelcast has this embedded mode, which basically means we don't need to create a Hazelcast cluster in order to leverage Hazelcast cache. We can build in the Hazelcast inside the application. And that's what we did, and it worked so well because despite we got a considerable amount of data, we just needed 3 instances of the application. So that is a good case for Hazelcast embedded mode. But if you start having too many application instances, and then all data needs to be duplicated across every instance, so we start wasting a lot of memory. But for a smaller number of application instances, like 3, that's not a burden. So rather than we create a client-server topology using Hazelcast, we opted for an embedded mode. That helped a lot in the setup. So that allows us to handle the high workload, but with extremely low latency, usually in average around 200 milliseconds. So thanks to Hazelcast embedded mode, we didn't set up any more infrastructure, and we managed to get a highly performant application with really low latency. That was great. So everything was fine. But we found a problem. The problem was, once in a while, we got a message from the SPS in order to update our inventory, where the message will have a number of items that was sold out. And then we had to update it accordingly our inventory levels. And that was fine when the number of items sold out was not so many, but when the more number of items used to grow, we realized that the application would start a transaction with Aurora and also with Hazelcast and update both. But because the number of items to be processed was large, the application used to take some time. And after a number of the items, the longer the process used to take, we start noticing some timeout exceptions. So every time we try to process a message with too many items, the we managed to update the database where when we try to commit the transaction on Hazelcast, Hazelcast would throw an exception, a timeout exception. And we didn't know why that was happening, because in our configuration, so Hazelcast comes with a really nice integration with Spring Boot. He implemented the transaction manager, the Spring transaction manager. So we got a Hazelcast transaction manager. And we had configured the Hazelcast transaction manager to use a higher value of timeout. So 300 seconds, so that was supposed to be more than enough. But we are having these exceptions with way below 300 seconds. So we got this puzzle, what was happening? And we start investigating the problem. And to fix this, we downloaded this Hazelcast source code, which is really nice code base to work on. Everything is really well organized. And we started with the, of course, the unit tests. And we found that the Hazelcast team created a testing layer, kind of a domain testing layer, DSL, domain specific language for tests, between the unit tests and Hazelcast itself. So I added some two new methods in this test layer in order to exercise Hazelcast in a transaction context. So I'm gonna create these two methods, put with delay and put with delay transaction timeout value. The only difference between them is one is annotated, both are transactionals, but one got a timeout configured as a Spring annotation. And basically, with this in place, where we can specify some time that the application will sleep before putting the data on cache, we are supposed to, depending on the configuration, we're supposed to have a timeout exception. With this code in place, and why I created this code, sorry, because we noticed that not only the transactional manager, the Hazelcast transactional manager, even configured with a default timeout, was throwing the exception, but also I tested using the transactional Spring Boot annotation in order to configure the transaction. In both ways, either way, I always end up with a timeout exception. So, okay, something was wrong. So I created this DSL with these two methods, and then we started test driving Hazelcast. The first test, which passed, was, okay, we are supposed to have no exception where we don't configure anything, no transaction timeout, that worked. But as soon as we added configuring a timeout, so we are supposed to have a timeout, and that failed. So even configuring a higher timeout, where we committed a transaction before the timeout, but sorry, on the other way around. We expect to have a transaction, a timeout, but even configuring the value, that didn't happen. So we realized that Hazelcast Transaction Manager was basically ignoring our transaction timeout configured in the annotation. And then we went after the code. And we spotted the problem. The problem was right here in the Hazelcast Transaction Manager. It got a doBegin method. And basically, what the doBegin method was doing, as we can read here on line 106, it was always creating a new transaction context, regardless the Spring transaction configuration. So what we did was, okay, that we got that, and so we structured, create a new method that we call get transaction context. And what we did was basically before creating a new context, looking up the screening configuration, the transaction options. If we had set up default a transaction timeout for that particular transaction, we would use it. Otherwise, if the transaction manager had a default timeout configured, we would pick that value up as well. With this small change in the Hazelcast Transaction Manager code, that was enough to fix the problem. So we came back to our tests, and then the test passed. And also, we added more case. So another case would be tested if the transaction times would the timeout if duration exceeds the default value, not anymore the transaction timeout value, but the default value configured in the transaction manager. And finally, we also create a test to verify if the transactional value, timeout value, would have precedence over the default value in the transaction manager. Also, that is important. So even if transaction manager has a timeout, default timeout for 30 seconds, for example, if some processing, some method is annotated with a higher value for the transaction or lower value, that should take precedence. So with this test in place, we test that, and everything was working just fine. When we deployed this in code in production, so everything just worked as a charm. And then that's why I opened this PR with the Hazelcast team, work with them in order to propose the fix. And that was accepted. So now this change has been merged, and hopefully now everyone can count with Hazelcast and Spring Boot integrated, and with the transaction configuration being really well, working as supposed to be. I would like to close this quick talk, which hopefully is not too fast, but I would like to share with you how we approach it to fix our production environment, even before we managed to get our proposal merged into Hazelcast. So because, well, we got the problem in production, we need to fix it. And of course, Hazelcast is busy. So up until the point where we start stock and they approved my PR. After that, also that would be merged and it would go into a release process. And we need to fix our production environment. So what we did was kind of a trick. We extended Hazelcast Transaction Manager using a bespoke version in our code base. And so in this extended version of Hazelcast Transaction Manager, of course, we can read here the do begin method. And what we did was, okay, let's just call the new get transaction context, the same that we fixed in the previous slide. But we had a problem. And the problem was, well, the do begin method got a transaction object, and that transaction object is a private attribute in the transaction manager, Hazelcast Transaction Manager. So rather than just change have access, in order to have access to that object because it's a private object, I had to use some reflection. So I basically serialized a value for this. I deserialized this object in order to have access to it, and then I using this object that now I got from the Hazelcast, I managed to pass that into the get transaction context. And when I got the response back, that also required us to do another trick, which basically was setting the transaction context holder in Hazelcast. And that also so required us to create some tricks using reflection, because that method was not available for using inheritance. So we needed to invoke the transaction, the method in transaction context holder using reflection, but that worked. It's just fine. And then with these two tricks in place, first deserialize your value in order to have access to the parameter, the transactional object, and finally setting the side effect that somehow this transaction context holder was applying. So that worked fine. When we implemented these two changes, we managed to get the get transaction context working, and all Hazelcast tests, unit tests, and integration tests passed. So with this safety net in place, because luckily, thanks to the Hazelcast team creating a really good safety net with unit tests and integration tests, we knew that that would work. And so we deployed this in production. And that's it. The solutions start working. We got no issues anymore. So
yeah, that's great to hear. Thanks very much, Denis. I think this is a really important message here. Like, you not only fix the issue locally, but also you submitted PR. So we got a couple of questions here. So my question is like, which Hazelcast version you spotted this issue on?
It was in a version 5, but also we fixed this in all currently supported versions. Okay. So the PR has been merged against I think the latest 3 versions.
Yeah, so for anyone is watching, basically you can upgrade this fix using the 5.3, which includes Denis PR as well. So they should have this fix as a in terms of like time frame, like how long it took to figure it out and submit the PR and get it merged. Can you just describe a little bit about this?
Sure, absolutely. So we got this problem looking at our console in Christmas. So I started working that right after the New Year. So that was beginning of January. Took me probably a week to figure out what's going on, looking through the logs, and then, okay, we got this timeout happening. So I downloaded the Hazelcast code and started debugging in my local environment. So yeah, that took me 1 week or so. And then during this week, I also came up with this local solution in order to fix my environment first. And with that in place, and like I said, wasn't so bad because I got a really good net of tests. So that helped me to figure out what's going on. With the test in place, I felt brave enough to push this into production, even having a really important application with a high workload. So a week after that, everything was fine.